We have two posts, one that's 12 feet high, and you can see that here in your diagram. The other is 28 feet high, and there's 30 feet in between. There's one wire going from the top of the post to the top of the other post, but hits the ground in between. Where should that stake be placed on the ground in between for the least amount of wire? Well, our total wire is really our first length and our hypotenuse of y plus your second length of your other hypotenuse, which is z. Well, we only want to have one variable over here. As we look at our problem, we're trying to figure out how far away, and so we're going to say that is x. If the whole distance is 30, then the other horizontal part would be the whole distance of 30 minus that x, so it's 30 minus x. So we need to then work with this triangle. What relates our x and our y in our 12? It's the Pythagorean theorem. Now we need to somehow not get two variables over here. You'll notice how x would show up in this triangle, x would show up in this triangle over here. So we're going to try to solve this first function for y so that we could plug it in and only have x's up there. Now you do go ahead and take the square root, but keep in mind since our y is a distance, it's only going to be positive, so it's only the positive square root. We're going to go ahead and do a similar situation for our other big right triangle with the z, using our Pythagorean theorem, solving it then for z so that we can plug it in up here. Once again, z is a distance, so it's only a positive root that we're looking at. Well, we now know that y is this, so all we're going to do is plug it in right here. And we have our z right here, and we're going to plug that in right there. Well, we plug in our y, we get this. Plug in our z, we get this. Well, the first root simplifies just a touch. Your second root is going to simplify more yet. You'll want to go ahead and FOIL your 30 minus x out. Then you're going to want to add your 28 squared, combine your like terms, and you get this. Now, let's talk about our domain. As you look at your problem up here, what's the smallest x could ever be? Well, that would be if your stake was right here. So the smallest x could be would be 0. What's the largest x could be? And that would be if it's over here at the other pole, which would be 30. So your domain is from 0 to 30. So you now want to go ahead and take your derivative, set equal to 0, and solve it. Remember here, you're going to have to use the chain rule and multiply it by the derivative of the inside. And this is what we'll get after our derivatives simplify. You then want to go ahead and set this equal to 0. If you go ahead and take this one here over to the other side, you'd have a fraction equal to a fraction. Then you could go ahead and cross multiply. When you cross multiply, that's how you get down to the next line. Now, we have variables inside the roots, so then you'll have to go ahead and square both sides. So you got to square your x, and you're squaring undoes your root. Square your parentheses and square your root. Now you're going to want to FOIL out the left side. After you square this, FOIL that out, then FOIL it times this. We get a nice big ugly looking problem. But you will notice you have some like terms on each side that are going to drop out. Then you're left with just a basic quadratic equation, which you could then go ahead and solve. It does factor. If you didn't feel like factoring it, you could use the quadratic formula. We get two answers. We get 9 and we get negative 22.5. But our only critical point we get is 9 because negative 22.5 is not in our domain. Well, you want to take your critical points, which is the 9, and your endpoints and plug them into your original function. Take 0, 9, and 30, plugging it into your original function. Now, whether you choose to plug it into this one here or this one here does not make a difference. They're both going to give you the same answer. Plugging in 0 gives you about 53.04. Plugging in 30 gives you about 60.31. When you plug in 9, it gives you 50. So therefore, we're looking for the minimum length of wire. We're going to want the minimum one. The stake should then be placed 9 feet from the 12-foot pole to minimize the distance or length of the wire.